Salt chemistry MCQs related to the stoichiometry, and these MCQs are most frequently repeated in ETEA and NMDCAT tests, Public Service Commission and NTS based tests. Part 3 of the video will cover a high difficulty stoichiometry MCQs. Total number of atoms in a compound may be calculated by the formula N, that is number of moles, multiplied by Avogadro number, N number of moles multiplied by molar mass, capital M represent the molar mass. Molar mass multiplied by mole multiplied by Avogadro number, mole multiplied by Avogadro number multiplied by total number of atoms in a given formula. So there is a formula for the number of moles that is equal to number of particle, number of molecule, number of atom divided by Avogadro number. So rearranging this formula, we will get the number of atoms. So the number of atom is equal to number of moles multiplied by Avogadro number. So number of mole here represented by the small n. So here n multiplied by Avogadro number. So this will be the correct answer. In a reaction, 32 grams of methane was reacted with an excess of chlorine gas. As a result, 177 grams of carbon tetrachloride is obtained. What is the actual yield of this reaction? 308 gram, 71 gram, 100 gram, 177 gram. So here in question 32 gram of methane is given and it will react with excess of chlorine and the product form will be 177 gram of carbon tetrachloride. Question is about the actual yield. So first we will know about the actual yield. What is meant by the actual yield? Actual yield is defined as the quantity of product that is formed in a chemical reaction, and it is different from the theoretical yield. That theoretical yield is calculated from the balanced chemical equation, while actual yield is the quantity of the product that is actually formed in a chemical reaction, or we can say the amount of product actually isolated in a chemical reaction. So here methane will react with chlorine, it will produce carbon tetrachloride and hydrogen chloride. So here 32 gram of methane will react with excess of chlorine and 177 gram of carbon tetrachloride is obtained. So the 177 gram of carbon tetrachloride, it is the actual product that is obtained from this reaction. So the actual product or actual yield is already given in the question, that is 177 gram of carbon tetrachloride. So there is no need to solve it. 177 gram is the answer. Ammonia is prepared in Haber process. What is the volume of hydrogen required for complete reaction with 200 cm cube of nitrogen gas? 100 cm cube, 200 cm cube, 50 cm cube, 600 cm cube. We know that ammonia is prepared by the combination of nitrogen and hydrogen gas. Here the amount or volume of nitrogen is given, that is 200 cm cube. Now what volume or what amount of hydrogen will be required in order to completely react with this 200 cm cube of nitrogen to produce ammonia? For this purpose we will first calculate their mole ratio. So nitrogen, it will react with hydrogen and it will produce ammonia. From the balanced chemical equation, 1 mole of nitrogen, it will react with 3 moles of hydrogen and it will produce 2 moles of ammonia. So their mole ratio is 1 mole of nitrogen will require 3 moles of hydrogen, which means they will react in the ratio of 1:3. In question 200 cm cube of nitrogen gas is given. So we will take 3 times of 200 cm cube for hydrogen. So 200 cm cube, this is the volume of nitrogen, and we will take 3 times, or we will take triple of 200 cm cube, that will produce 600 cm cube. That volume will be required for hydrogen, which means that 600 cm cube will react with 200 cm cube of nitrogen and it will produce ammonia. So 600 cm cube is the answer. Vitamin A is the formula of C20H30O. How many molecules are present in 500 milligram of its capsule? Avogadro number 1.05 into 10 to the power 21, 0.02 into 10 to the power 22, 3.01 into 10 to the power 23. So we will solve it. Number of molecules that has formula, that is equal to moles multiplied by Avogadro number, and mole is equal to mass divided by molar mass. Molar mass of vitamin A is 286 gram per mole and the mass given is 0.5 gram, because here 500 milligram is given, so we will convert it into gram. We will divide it by 1000, so we will get 0.5 gram. So this is the mass, this is the molar mass. Putting these value in the above equation, 0.5 divided by 286 multiplied by Avogadro number is in formula. We will get 1.05 into 10 to the power 21 molecules. So the answer B is the correct answer. Number of covalent bonds in 9 gram of water are Avogadro number, 2 multiplied by Avogadro number, 3 multiplied by Avogadro number, 4 multiplied by Avogadro number. So we will find the number of covalent bond. Solving it, first we will find the number of moles for 9 gram of water. Then we will find the number of molecules, and from that we will find the number of covalent bonds that are present in molecules. So the number of mole that has formula is equal to mass divided by molar mass. Mass is given in the question, that is 9 gram of water. 18 is the molecular weight or molar mass of water. So we will get 0.5 moles. Now 0.5 moles, it is equal to the 9 gram of water. Number of water molecules that has formula, number of moles multiplied by Avogadro number. So number of moles are 0.5 moles multiplied by Avogadro number. We will get 3.011 into 10 to the power 23 molecules. So these number of molecules are present in 0.5 moles. And 0.5 moles are equal to the 9 gram of water. Now we know that one molecule of water has 2 covalent bonds. 2 covalent bonds mean that one covalent bond is present between oxygen and hydrogen, and second covalent bond is present between oxygen and second hydrogen. So there are 2 covalent bonds in a single water molecule. So we will calculate the number of molecules that are 3.011 into 10 to the power 23 molecules. This much of the molecule has how much of covalent bond? So 3.011 into 10 to the power 23 molecules of water will have how much of covalent bond? So multiply it with 2. So 2 multiplied by 3.011 into 10 to the power 23, we will get 6.022 into 10 to the power 23 covalent bond, that is equal to the Avogadro number. So this is very simple. First we will find the number of mole using the gram that are given in the question. From the number of mole we can calculate the number of molecules, and from the number of molecules we will calculate the number of covalent bonds. So the answer is equal to the Avogadro number 6.022 into 10 to the power 23.